ready to move your body tonight? Are you ready to move your body tonight?
Good afternoon, welcome to lesson 3.1. We're starting topic 3 today, and in topic 3 we're going to be talking about operations with decimals. Today, to get started, we're going to be talking about estimating sums and differences. So you already know how to round decimals, but what we're going to do today is we are going to estimate sums and differences of decimals. So if you remember, a sum is just the answer to an addition problem, and a difference is the answer to a subtraction problem. So to get started, I want you to think about a time that you might need to use this. When would this be helpful? When would this be useful? Is this just something we're doing in class, or is this something that we can use in the real world? Well, sometime that you might need to round decimal or to estimate decimals when you're doing sums and differences might be when you're at the grocery store. If you have $20 in your pocket and you have a couple items that you want to buy and you're not sure, well, you can just estimate the sums and differences. I know that a can of peaches is $2.97 and a can of tuna is $4.93, and then a box of Twinkies is $1.99, right? I can just estimate the sum of that and see if I'm going to have about enough money to cover that cost. Or another example would be when your parents are driving in the car. You might want to see how far you traveled for the trip, so rather than saying we drove exactly 27.2 miles, we could just say we drove about 30 miles, or we drove 27.2 miles to Quick Trip, and then we went down south to Branson and we drove 294.27 miles, right? We can just estimate that. We can estimate that sum with the decimals. So that's what we're getting into today. Let's go ahead and take a look at it.
Ready to move your body tonight? Are you ready to move your body tonight?
So now we're in our PBIL section. Make sure you're there with me and write down everything that I write, okay? I'm going to start off just by reading our problem. And here's what it says. One northern town received 13 29/100ths of an inch of snow one year and 6 54/100ths of an inch the next year. About how much snow did the town receive altogether in these 2 years? You're going to work with a partner to solve this problem. Well, you don't get a partner today, you get me as your partner. It's even better, right? So here we go. I'm going to write down all the information that's important, right? The first year, there was 13.29 inches of snow. So that's year one. That's what I'm going to write down first. 13.29 inches of snow. The second year, there's 6.54 inches. So this is year two. What this problem is asking us, though, it says about how much snow did the town receive altogether? Well, do we need to find an exact or approximate answer for these two numbers? Well, the question says about, so what we can use is an estimate. Remember, that word is in your vocabulary that we wrote down this morning. So make sure that we remember that with that word about, it means we can use an estimate. We don't have to find the exact answer. So what we're going to do is we're going to look at a couple different ways that we can find an approximate answer or an estimate for this question. Let's take a look. One way to estimate a sum is to round to the nearest place value. So let's look. I could either round this to the nearest tenth, or I could round it to the nearest ones. What I want to do is let's first start off rounding it to the nearest tenth. So you should already have this part written down, so leave yours. And below that, you're going to write what I write now. So if we know that 13.29, and we also have 6.54. If I want to estimate this to the nearest tenth, I'm just going to round that to the nearest tenth. So to remember, to round, I'm going to look at the value that I'm looking at, the place value. I'm looking at the tenths, and I look at the digit to the right. Depending on this digit, if it's greater than 5, then the digit that I'm doing the place value will go up 1. Or if it's less than 5, it's going to stay the same. So is 9 greater than or less than 5? Well, 9 is greater than. So because of this 9, I know that 13.29 rounds to 13.29. PH is important. Tens is different than tenths. If I'm rounding 6 and 54 hundredths, then I look, if I'm wanting to go to the tenths, I look at this 4. Is it greater than or less than 5? Well, it's less than 5, so rounded to the nearest tenth, this is going to end up being 6.5. So if you notice, I lined up my decimals here when I was moving them over. And that's to make it easier for when I add them now. When I add, I'm going to add the place values. 3 plus 5 is 8. I'm going to bring down my decimal. And 3 plus 6 is 9. And I bring down my 1. So when we estimate, or we approximate this answer, then this Texas town received approximately 19 and 8/10 or 19.8 inches of snow. So that's the first one. We could round this one to the tenths, right? It's more approximate. It's not our exact answer. It's not the exact amount that they got. So go ahead and make sure you have this down in your PBIL. And I'm going to move on to the next section. So I'm going to erase this here. So again, we start with 13 and 29 hundredths, 13.29 inches. And we also have 6 and 54 hundredths. So what's another way we could round this? Well, the other place value we could look at is the ones place, right? So the same thing. I'm going to look at the place value that I want to round to. I'm looking at the ones. Then I look at the place value directly to the right of it, and I look if it's greater than or less than 5. For this one, 2 is less than 5, so my 3 gets to stay the same. So when I'm rounding to the ones, this is 13. When I'm looking at my ones place of the 6, I look to the right, and this 5 is greater than or equal to 5, so this is going to round up to 7. Now from here, all we have to do is add 13 plus 7, and we know that it's 20. Inches, not inches. So, from there, we can just look and see that there's approximately, a good estimate would be 20 inches of snow for this Texas town. We're going to take a look at a few more examples, so stick with me. Go ahead and flip to your guided practice section now, and we're going to take a look at a few more examples. I already have number 1 written on the board for us, and that's what we're going to take a look at. So make sure you write number 1 down as well. I'm going to give you a second to do that. For number 1, we're not going to want an exact answer. What we want is to approximate. We want to find an estimate. But for this estimate, what the problem is going to ask us is to round to the nearest tenth. So our estimate is going to be based on rounding to the nearest tenth. So how do we do that? Well, all we have to do is first round to the nearest tenth. So this answer, I'm just going to go straight down, rounding to the nearest tenth. Go ahead and write nearest tenth as well above your guided practice so that you remember that this problem is an example of rounding to the nearest tenth. So when we do this, what I have to do is, remember, I look at the place value that I want to round to. Then I look to the number directly to the right, and I see if it's greater than or less than 5. Well, 6 is greater than 5, so that 7 is going to turn into an 8. Once I reach the place value that I want to round to, everything else doesn't matter. So I can plug in zeros, or I can just leave it just as 1.8, right? But it's going to be 1.8 or 1 8/10. When I round 0.686 or 686 thousandths to the nearest tenth, all I care about is this tenths, right? So I'm going to look at my tenths, and the number directly to the right is bigger than 5. So that tells me that this is now 7/10. My 6 has to go up a number. And now that I know my tenths, I don't care about anything else. So I can either plug in zeros for them, or I can just leave it as 7/10. That's the same number, right? So now to estimate this to the nearest tenth, all I have to do is add my two numbers. So remember, when we're adding decimals, we have 1.8 or 1 8/10 plus 7/10. Remember, it's important, line up your decimals. If your decimals aren't lined up, we're not going to be adding the same place values. So 8 plus 7 is 15. I'm going to carry my 1. I'm going to bring down my decimal. And 1 plus 1, problem of the day right here, is 2. So 1 and 769 thousandths plus 6 and 686 thousandths rounded to the nearest tenth is just 2.5. So that's number 1. Make sure it's in your guided practice, and we're going to move on to number 2. I apologize, I realized that bottom part was cut off. But remember that last answer was 2.5. So that last part we were adding the numbers up, it got cut off, but it's 2.5. So what we're going to do now is look at number 2. Let's check it out. Again, we're rounding to the nearest tenth for this problem. We have 20 and 45 hundredths plus 13 and 15 hundredths, or 20.45 and 13.15 if you want to be all easy peasy on it, right? So we're rounding to the nearest tenth. So again, we're looking at the place value. If you don't know your place values, use a place value chart. Use something that's going to help you, because if we can't figure out our place values, we're not going to be able to round to the appropriate place. So we have 20 and 45 hundredths. I'm going to look at my 4 for my tenths. Again, I'm just going to look right below it. 20 stays the same. And to get to the tenths, I look at the digit to the right of the tenths. And this 5 is greater than or equal to 5. It's actually equal to 5, right? So I know that my 4 turns into a 5, because that means this number increases. And then I don't care about anything. Once I figure out which place I'm rounding to, I leave it alone. So I'm going to leave that there. I'm not going to put my 0 in this time. You can if you need to. And then we're going to look at this one. My 13 is going to stay the same. And I'm at 15 hundredths. Well, I'm looking at the tenths. I want to round to my nearest tenth. So I look to the digit to the right to round. Again, 5 is greater than or equal to 5. It's equal to 5. So my 1 now turns into a 2. And again, I'm going to leave off these zeros, because once we get to our place value, it doesn't matter. It's 0, 0, 0, 0, 0. It goes on. Or I can just leave my 0 because there's 0. There's nothing there. So now I'm going to line up my decimals again. So I have 20.5 plus 13.2. Well, I'm just going to bring this down around here. And I'm going to put 13.2. And I'm going to add these together. 5 plus 2 is 7. We're going to bring down the decimal. 0 plus 3 is 3. And 2 plus 1 is 3. So our answer for number 2 in guided practice is going to be 33 and 7/10. That is this expression rounded to the nearest tenth. We're going to look at 2 more examples. So go ahead and make sure you have this copied down. Stick with me, and we'll look at number 3. Here we are at number 3. What I'd like you to do is take note that now we're rounding to the nearest whole. So in your guided practice section, make sure you write a little note to yourself that we're rounding to the nearest whole number now. So let's look at how we round the nearest whole number. The nearest whole means we're going to get rid of everything after the decimal. So what that means is we're going to be rounding to the ones place. So let's look. In my ones place, I have a 1. So that means I look directly to the right, and there's a 4. 4 is less than 5. So this rounds to 1. I'm going to look at the next part, 5.4. I'm looking at my ones, and I look directly to the right. There's a 4. 4 is less than 5, so my 5 gets to stay the same. And now 14.08, or 14 and 8 hundredths. We have a 4 in the ones, and a 0 in the place value directly to the right of it. 0 definitely is not bigger than 5, so the 4 gets to stay the same. So 14. Remember, we are rounding to the nearest whole. So once we get to that decimal, since we're at the whole, that's also known as the ones, right? It's just going to be gone. Everything after the decimal doesn't matter. We figured out what we were looking for. So now, all we have to do is simply add 1 plus 5 plus 14. Once we add those together, 1 plus 5 is 6. 6 plus 14 is 20. So this expression, rounded to the nearest whole, is going to give us an answer of 20. So make sure you have this copy down. We're going to move to our last problem, number 4, and then I'll set you loose on your quiz, and I'll see you in class tomorrow. We've arrived at number 4, and what I want you to do is make sure, again, we're rounding to the nearest whole, and this is number 4. But what I want you to do is make sure you take note. Look at our operation this time. Look at our sign. We're not adding anymore. Now we're looking at the difference. We're using subtraction. So, rounding to the nearest whole to estimate, we're estimating the answer to the nearest whole. We're going to do the exact same thing we did before, but instead of adding, we're going to subtract. So 72.43, 72 and 43 hundredths. What we're going to do is we're looking for the nearest whole. So I'm going to underline my ones place. Make sure you're doing this too so that you can have a good example for later. So when I look at my whole number, that means once I'm done, I'm not going to have a decimal. I only care about the whole, right? So now I'm going to look at my ones. I'm going to look directly to the right. 4 is less than 5, so my 2 gets to stay the same. It doesn't need to change. So now we're looking at 72 minus, remember our sign, 59.8. Well, 0.8 or 8/10 is bigger than 5. So what I'm going to do is I'm going to round this. But since there's a 9, 59, what comes next after 59? Well, the next ones place is going to be a 0. It's going to be 60. So now, since we've rounded this to the next biggest thing we can get to, 59, 60, we're going to do 72 minus 60. 72 minus 60 is 12. So this expression, 72 and 43 hundredths minus 59 and 8/10, rounded to the nearest whole, estimated, our difference is 12. So make sure you have those down in your notes. If you are confused on any parts, go ahead and watch those again. And go ahead and take your quiz. Remember to email me your score. Put your score out of 5 in the subject line, and I will see you in class tomorrow.